All right, so in this unit, we're going to make heavy use of Bohr models to help build our structure of the atom and model where our electrons are moving, either within an atom or eventually between different atoms. So in a Bohr model, you can see that the skeleton of it here in this circular diagram. In a Bohr model, the circles around a nucleus represent energy levels. So each of those circles we're going to call an energy level. So starting from the center, you can see the positively charged nucleus in the middle there. That's just represented with the plus. So this is going to be our positively charged nucleus. So each level is represented by one ring. So we would call this level 1. Every energy level, the way that the letter that we use to abbreviate it is called N. So this would be N equals 1, meaning energy level 1. This would be N equals 2, N equals 3, so on and so forth. So what this is saying is that an electron can exist in these different energy levels, and they do so by sitting on these rings here. So this model illustrates that energy of electrons is what we call quantized. So being quantized means you have a specific packet of energy, essentially. So over here in our notes, quantized refers to the fact that electrons have specific little packets of energy. And these energies are basically quantities or levels. The language that we use to represent this is we say that 1 quantum equals 1 energy level. So quantum level 1 would be energy level 1. So these electrons in this Bohr model exist in these rings, right? Well, what happens, can they move between these different energy levels? Can they move between the rings? So turns out, yes, they can, but there are a couple rules to electron movement here. So electrons don't just randomly jump between energy levels whenever they feel like it. They have to get some energy in order to do so. So they can jump between energy levels, but they won't do it until they get the right amount of energy. So electrons do not So electrons can't just jump between energy levels. They have to get the right amount of energy to do so. To move up or down energy, to move up an energy level, they have to absorb some energy. To move down an energy level, they have to release that energy. So electrons will stay at their energy level until they gain or lose energy from the surroundings. All right, so they will stay at their energy level until they gain energy from or lose energy to their surroundings. So how can an electron move between energy levels? This is what you're going to kind of take a look at in part 3 simulation. But just to get you used to what you're going to see, I have a picture of what the simulation kind of looks like down here. So you have a Bohr model there on the left. The small blue dot represents an electron, so you can see it blown up over here. Each of those dotted lines is going to represent an energy level. That bolded line at the bottom represents the energy level at which your electron is starting. So everything in the universe is extremely lazy. It wants to be in its lowest possible energy level. If it is in its lowest possible energy level, we call this the ground state of the electron. If an electron moves to a higher energy level, we call it then an excited state. So each of those dashed lines there would represent an excited state. And this lowest level here would represent the ground state. So as you move farther away from the nucleus, you're actually getting higher in energy levels. So your energy is going to increase as you move away from the nucleus. So an electron can emit or absorb energy. If it absorbs energy, it's going to take that energy into itself. That pushes it to a higher energy state. If it emits energy, it's going to release it to its surroundings to fall back down. So I'll give you one example of each of these so you know what it looks like when you get to the simulation. So in an orange arrow, I'm going to call this absorb. And in a pink arrow, I'm going to call it emitting or releasing. So if that electron gets some energy and pushes itself to an excited state, that's the arrow it would look like right there, and then our electron would end up showing up there. Then if an electron emits energy, it's going to fall to a lower energy state, so our electron would end up right back down there. So this is what you're going to see in the simulation. So go ahead and stop this video, head back to the simulation, and move on to part 3, exciting electrons.